Hello everyone, this is our class 11 and this is the third class from 4.3, which is graphing rational functions. So we have these things for our this class, like some review and some from graph to equation. How do we get equation from the graph? So this is the main thing for this third class. Then we have another important thing, quiz to date and topics, etc. First of all, this one is the homework review kind of, and then you can see this is the question and this is the graph. So from the question, we need to find out all the details. What is the domain, y-intercept, x-intercept, vertical asymptote, horizontal asymptote, etc., etc. from this question. So you may have a look if you finish this one, and then the graph is this. And just a quick, just for a quick note, the domain will come from here and from the denominator, and the vertical asymptote also will come from the denominator. Then the horizontal asymptote, see this is x and the power is 2 here, x into x means x squared, so y equal to 0. This way we get the decision. And then x-intercept you can find from this, x equal to 0 will be x-intercept. And then near behavior also similarly we can find behavior near x equal to 0, etc., etc. Then we have different intervals. From the different intervals, these are the additional points in different intervals. Then we can plot it and draw the graph. And these are our basic six rules by which we draw some graph. This is the thing. This one is like, how do we know that which one is which graph? So you will see it from here. This one is x, that means x-intercept is 0 and 0, that's why the x-intercept is 0 here. And see, the power of x is 1. If power of x is 1, then it will cross at 0. Here power of x is 2, that's why it just touch. The reason is this. The reason is power is 2. Again the power is 3, that's why again it crossed it. So if the power is odd, then it will always cross. If the power is even, then it will touch at the x-intercepts. And then we have this now from the denominator, how this denominator will impact our graph. See, this one is from the denominator, we know that our asymptote, our vertical asymptote will come. So you see our vertical asymptote is x equal to 1, which is here. X equal to 1 is somewhat in the middle here. And if we have this, so you see this, the power of x minus 1 is 1. That's why you see one line is going up, one line is going up, then one line is going down. See, this side is going down and this side is going up. Within this box you can see one side is going up, one side is going down. The reason is the power is 1. That is the reason. And here you will see the difference more clearly. You see both of the line is going up. This side is going up and this side is also going up. The reason is here power is 2. If power is 2, then the both of the lines which is coming towards the asymptote, both of the line will go to the same direction. Then it means power will be 2, 4, this kind of even number. Even number means both of the line will come from the same direction. And see, this one is one line going up, another line is going down. This is for asymptote minus 2, and minus 2 is here. At minus 2 there is some asymptote, and the reason is the power is 1. This is the reason. Same goes for this. See, for this one both goes to the up direction. For this one goes up, one goes down. So this is how we know from how the vertical asymptote's power impacts the graph. This is how we know. Now this one, let's look at this, what's going on here. First of all, you see x, the crosses x-axis at 0, which is here, crosses x-axis at 0, that's why we have this. And then touches x-axis at 2, so we have this, touches x-axis at 2, that's why we have this thing, x minus 2, then whole squared, y minus 2, because this is plus 2, touches x-axis at plus 2, that's why this plus 2, that's why plus 2 whole squared. Then we have these things goes in the opposite direction near x equal to 3. So x equal to 3 or x minus 3 will be the factor here. X equal to 3 is the asymptote. This is the asymptote, x equals to 3. So this is the x equals to 3. See this opposite direction. This one is going up, this one is going down. That means for x equals to 3, this x equals to 3, power will be opposite direction means power is 1. Same direction means power is 2. Same direction is for x plus 1, which is here, x plus 1. For x plus, How do we know that x plus 1? See, this is for if our asymptote is x equal to minus 1, then factor is plus 1. This one, for this one, and same direction means power is 2. So this power 2 we gave from ourselves, because we can see the graph is coming to the same direction from the both direction. By both direction I mean, see, from this direction and from this direction, so from the both direction. This is how we can make some equation. We can make some equation. This is how, and see, y horizontal asymptote at y equal to 1. How do we know that here horizontal asymptote is at y equal to 1? The reason is x into x means x into x square, total is x cube, and x into then again x square, total is x cube. That means x cube is on the up and x cube is in the bottom. So basically our horizontal asymptote will be the coefficient here and here. So there is nothing, that means 1. There is nothing here, that means 1. So 1 by 1 means this one. This is how we get the horizontal asymptote. So everything will match. The point is that. So the thing is, this is how we get from the graph and from the information we get the equation. This is how. Now see this one, 23 number. This is some graph, like this kind of graph is given. Let's say this 23 number graph is given. Then how do you find this equation? So see, first of all, there is a vertical asymptote. The vertical asymptote is at x equals to plus 2. So it will be minus 2. X minus 2 will be there. Then we have x-intercept at 0. So x-intercept 0 means only x, because we cannot give anything here, because it is 0. 0 means x plus 0 or x minus 0. You can write that. And x minus or x plus 0 means x again. That's why we do not have to give anything. Then there is some horizontal asymptote here at y equal to 1, but you have 1 here and 1 here. So that's why y equal to 1 is also matching there. So we do not have to do anything else. This is how this 23 number and here both of them are matching. 24 number, this question is, how do we get this equation series? First of all, is there is any x-intercept? See, there is no x-intercepts here, so that's why there is no x here in the top. Okay. Then there is some asymptote here. Asymptote is where? Asymptote is at minus 1. So our factor will be x plus 1. And why it is square? Square, the reason is, see, from this direction graph is coming to the asymptote. From opposite direction also graph is coming towards the asymptote, and from the same and going to the same direction. Both of the graph is going up. This is going up. This is also going up. That's why power will be even. If both goes up from the both goes up or both goes down, both in the same direction, it is going up, it is also going up, then power is 2. So power is 2. And to match with this y-intercept, we give this 2, because as you can see, if I put x equal to 0, then see, 2 divided by 1 means 2. X equal to 0 means y-intercept. So to match this y-intercept, we gave here 2. If there is no y-intercept, then it will be just only 1 in this kind of situation. But normally there are some other things also related to the equation, as we have seen in the previous slide. So this is how we actually come to our algebraic form or rational function form from the graph. This is how they are related. And this is our quiz to topics and other things. So this will be Tuesday and Wednesday. There will be another Tuesday and Wednesday, February 8 and then 19 minutes. There are different sections, so they will give the exam in different date. Tuesday and Wednesday, it will be like that. In class 60 to 70 minutes, and allowed notes and non-graphing calculators. Not allowed this. These are not allowed. So the questions, like, these are our possible topics: domain of rational function, particular asymptote, horizontal and oblique asymptotes, let's say from the given function. Then wholes caused by cancelling the common factor, how a whole comes. Then finding the information from the rational function and from the graph and from the rational function. You have to find the information. Find information means, suppose a graph is given. From the graph, now you have to identify what is the vertical asymptote, horizontal asymptote, intercepts, etc. from the graph. And then suppose some equation is given. From the equation, we have to find out the same thing, vertical asymptote, horizontal asymptote, etc. from the algebraic equation. Rational function, definitely. From the rational function, we have to find out all this information. Then sketching the graph of a rational function from its equation means, suppose a equation is given, equation of some rational function is given, then from the rational function we have to draw the graph. And as you know, to draw the graph, we need to find out a couple of things, like what are the asymptotes, what are the x-intercepts, y-intercepts, then the shape of the graph. We need to, for shape of the graph, we need some additional points. This is how we actually draw some graphs of rational function. So last one is the drawing. So these are pretty much everything about this quiz, and definitely from 4.2 and 4.3 as well. So if you just go ahead with this, everything should be fine. And then we have the homework thing as usual. There is a couple of homeworks, etc. All right. Thank you all. Thank you very much. Bye bye.